All right, let's just go ahead and forget everything Hollywood has ever taught you about air combat. Seriously, the days of hotshot pilots pulling insane high-G maneuvers in close-in dogfights, relying on nothing but raw instinct and a steady trigger finger, that's all fading into the history books. Welcome to today's Explainer. Today we're putting on our military strategist hats to look at the very real, very complex future of modern warfare. We are entering the era of the multi-domain kill web. And in this new world, the aircraft itself isn't really the primary weapon anymore. It's actually the central nervous system of a massive, highly intelligent network. So right off the bat, we have to ask the big question. Is the era of the dogfight truly over? Well, from a purely strategic perspective, the answer is a resounding yes. The future of air superiority just isn't about having the absolute best individual pilot reflexes anymore. It's entirely about creating the most adaptable, expansive, and resilient network out there. It's about seeing the threat first from literally hundreds of miles away and neutralizing it beyond visual range, what we call BVR, long before a human eye ever even makes visual contact. Okay, so here's our intelligence briefing agenda for today. First up, we'll hit the technologies of the kill web. Second, the F-47 distributed network. Third, the J-36 airborne battleship. Then we'll cover GCAP and global allies. And finally, we'll try to assess who's actually winning the race. Let's dive right into Section 1, Technologies of the Kill Web and this entirely new paradigm. Now, to survive heavily defended anti-access and area denial environments, often called A2/AD, we need a completely different approach. And it's built heavily around collaborative combat aircraft, or CCAs. But listen, these aren't your standard remote-controlled drones. We are talking about highly autonomous loyal wingmen. This concept of manned-unmanned teaming fundamentally shifts air combat from single fighter jets to a massive system of systems. Imagine a single pilot directing a whole swarm of CCAs flying miles ahead as attributable assets. They're out there jamming radar, scouting targets, or even launching kinetic strikes on their own. And you really have to appreciate the sheer scale of capability required to pull this off. We're just talking about, upgrading the radar here. We're talking about onboard artificial intelligence conducting cognitive electronic warfare, literally learning an enemy's jamming patterns in real time. We're looking at all-spectrum stealth that hides thermal and acoustic signatures, not just radar returns. And directed energy. Yes, we are talking about literally using lasers as close-in weapon systems to shoot down incoming missiles. It's wild. But here's the catch. To power those lasers and massive AI processors, you need an unbelievable amount of electricity. Which brings us to engine philosophy. Traditional static jet engines are usually optimized for either fuel efficiency or high thrust, but rarely both at the same time. The sixth generation absolutely demands variable or adaptive cycle engines. Think of it like a fuel-efficient commercial jet during a long cruise that suddenly morphs midair to generate the massive thrust and electrical power required for directed energy and cyber weapons once combat starts. It's essentially cheating physics, hopefully without voiding the warranty. Moving right along to Section 2, the F-47, the distributed network, and the ultimate quarterback. Let's take a look at the American contender under the Next Generation Air Dominance, or NGAD program. The U.S. strategy here fundamentally relies on distributing risk and capability across a network. The Boeing F-47 isn't actually designed to carry every single weapon or sensor itself. Instead, its whole philosophy is to act as the ultimate quarterback in the battlespace. It hangs slightly back, safely processing massive amounts of data and calling the plays, directing those CCA drone swarms deep into contested airspace, rather than putting all its firepower and the human pilot into one vulnerable airframe. Back in 2020, we actually saw an AI algorithm successfully perform in-flight tasks on a U-2 Dragon Lady. And this is a perfect illustration of the path to this incredible level of AI integration. In a sixth-generation jet, the pilot's role is going to completely shift. They transition from being a mechanical operator just flying the aircraft to a strategic decision authority. The AI absorbs the immense cognitive load, filtering all that complex threat data, so the human pilot simply authorizes the broader tactical moves. Which brings us to Section 3, the J-36, the airborne battleship and concentrated mass. So while the U.S. is distributing its power, China is taking a fundamentally different approach. They are concentrating it. The Chengdu J-36 operates on a truly massive scale. We're talking an estimated 50 to 60 metric tons. Guys, that means you are essentially strapping jet engines to a main battle tank. It's a massive, tailless flying wing that reportedly utilizes a tri-jet configuration. That's 3 engines. Why on earth do you need 3 engines? to maximize range and generate the absolutely staggering electrical output needed for long-duration regional control and heavy directed energy payloads. When we look at a head-to-head comparison of these design philosophies, they literally couldn't be more different. Where the US uses a single pilot, aided heavily by AI, to penetrate deep into enemy lines, China employs a side-by-side dual crew setup. One person flies the massive jet, and the other manages the drone swarms and electronic warfare. It's truly an airborne battleship designed specifically for deep Pacific endurance and keeping adversaries far, far away from their shores. And what's truly fascinating here from an industrial strategy standpoint is that China isn't placing all its bets on one single airframe. They are uniquely accelerating their development velocity by running a dual-track hedging strategy. So alongside the massive Chengdu J-36, we're also observing the Shenyang J-50, which appears to be optimized for carrier operations and multi-mission flexibility. It's essentially a parallel competition. It's a lot like how Silicon Valley runs competing internal teams just to ensure at least one breakthrough succeeds. All right, Section 4, let's look at GCAP, global allies, and the combat cloud. Because this race isn't just a two-player game between the US and China, the Global Combat Air Program, or GCAP, is a massive trilateral effort between the UK, Italy, and Japan. They recently awarded a huge contract to the Edgewing joint venture, and their strategic doctrine relies heavily on what they call the combat cloud. See, they aren't just building a jet, they're building a super-connected node. It's meant to seamlessly integrate, beyond visual range, with allied naval destroyers, military satellites, and ground assets to ensure their own sovereign air superiority. So, finally, Section 5, winning the race. Let's talk timelines and costs. When you look at the timeline, China currently has a highly visible head start in physical flight testing, with the first flights of their prototypes actually observed in late 2024. The US, on the other hand, is leaning heavily into a digital engineering and simulation-first approach. They're targeting a first flight for the F-47 in 2028. But both nations are aggressively pushing for initial operations in the early 2030s, while the GCAP coalition is targeting 2035. But look, timelines only really matter if you can actually afford the hardware. And this number, $300 million, brings these futuristic defense concepts violently back to reality. That is the estimated cost of a single American F-47 fighter jet. When you combine that astronomical price tag with the cost of thousands of autonomous wingmen, plus the vast network infrastructure required just to run them, you face the very real threat of completely unsustainable defense budgets. To summarize the core strategic takeaway of all this, I want you to consider this perspective from defense analysts. China's approach produces powerful platforms. America's approach produces adaptable systems. And that's absolutely crucial. The ultimate winner in the sixth-generation race isn't necessarily the nation that builds the jet with the highest top speed or the biggest missile base. It's the nation whose digital and network architecture scales and adapts best over the next 50 years. Which leaves us with one final critical question to ponder. As AI begins to authorize targets, and as costs literally skyrocket into the hundreds of billions, will these autonomous kill webs truly secure the skies of the 2030s? Or is there a very real risk that these incredibly complex, multi-billion-dollar systems will ultimately collapse under their own cognitive and financial weight? It is a massive strategic gamble, and the cost of failure is literally the loss of the skies. Thanks so much for joining me for this explainer.